Hello students, welcome back to Science Capsule, a perfect self-learning tool for school children. This is episode number 2 where we will learn about the chemical properties of metals and non-metals. If you have not watched episode number 1 about the basic things required to metals and non-metals, please find the video link on the I button and I will also provide in the description, and the playlist is available where you can watch all the 4 videos to learn complete chapter, that is metals and non-metals. For your convenience, timestamp is available in the description where you can skip some part of this video. Whichever part you want to like to continue, that can be clicked directly and viewed. And this video is very important as far as this chapter is concerned, so watch till the end of this video. If not subscribe this channel, subscribe this channel and press bell icon, because more and more videos on science subject will likely to be uploaded in the near future. So without wasting much time, let us start today's episode. In today's episode, we are going to learn about various chemical properties which are very important as far as the examination is concerned, as per as the personal knowledge. The first chemical property what we are going to learn is what happens when metals react with air. Basically, when metals are exposed to air, in simple words we can say that metals react with oxygen. Air means oxygen, it forms metal oxide. So this is the basic reaction. Let us see various chemical equations to support this chemical property. Let us start with the general equation. We know that when metal reacts with the oxygen, this general reaction needs to be understood. Here we get metal oxide. Dear students, almost all the metals react with oxygen to form metal oxide. Let us take some of the examples to understand this. Students, when copper is heated in air, then what happens? It reacts with copper, a black color copper oxide is formed. So this is the chemical equation. So in order to balance this, we write here 2, here 2. So a black substance is obtained when copper is heated in presence of air. So this is here metal and here oxygen, copper oxide, that is metal oxide. Got it? Likewise, aluminium also reacts with the oxygen. Aluminium reacts with the oxygen, gives aluminium oxide, that is Al2O3. Here zinc, when reacts with the oxygen, gives zinc oxide. These two oxides are called amphoteric oxide. Amphoteric oxide. Dear students, in the previous chapter we have learned that metal oxides behave basic in nature, which means when dissolved in water it forms a base and they tend to react with the acid to form salt and water. We learnt it as a neutralization reaction. So basic idea of a metal oxide is it behaves basic in nature. It's not true for all the metal oxides. There are certain metal oxides which behave both as acidic and basic. So the metal oxides which behave both as acidic and basic are known as amphoteric oxides. Dear students, most of the metal oxides do not react with water or dissolve in water. Some of the metal oxides dissolve in water and forms alkali, which is a base. For example, sodium oxide is there, potassium oxides are there. All these can dissolve in water and form alkali, and which acts as a base. Let us see how these metal oxides react with water. So here sodium is the metal, and when it reacts with oxygen we get sodium oxide. When it reacts with water, sodium oxide can dissolve in water and forms an alkali. Here we get NaOH. So in order to balance this, here 2 and the reaction got balanced. So here we can clearly see that sodium oxide dissolves in water and forms a base. So this is called alkali. Got it? Likewise, you see potassium can react with the oxygen and forms potassium oxide, and when it dissolves in water then we get KOH. So to balance this, so the reaction is balanced. Here the metal oxide dissolves in water and forms a base. Such type of base is called alkali. The second chemical property of metals is what happens when metals react with water. So, very important class of chemical properties. Here what happens, the chemical reaction takes place in two steps. In the first step, as you can see on the screen, metals react with water and forms metal oxide and hydrogen gas. So, this is the first step. In the second step, what happens, the formed metal oxide once again reacts with water and forms metal hydroxide. So, in simple words, we can say that when metals react with water, metal hydroxide will be produced. So, this is how we can understand. So, in order to support this, let us see some of the examples, some of the chemical equations to understand in a better way.
Dear students, the reactivity of metals with water is different for different metals. Some of the metals can react even with cold water, some of the metals react only with hot water, and some of the metals react only with steam. Let us see all those with some examples. Firstly, we will see what are the metals that react with the cold water. For example, potassium and sodium are so vigorous with water, highly reactive towards water. Potassium reacts with the water, we get potassium hydroxide, and here hydrogen gas will be evolved. And this chemical reaction is highly exothermic. You must have studied what is exothermic reaction, right? Which means large amount of heat is liberated, and this heat is sufficient to catch fire. So, during this chemical reaction, hydrogen immediately catches fire due to exothermic nature of this chemical reaction. Likewise, if you see sodium reacts with water, similar kind of reaction we will see here NaOH and here hydrogen gas. Here also this chemical equation is also highly exothermic, so large amount of heat is liberated. This heat makes the hydrogen gas catch fire quickly. So, if sodium and potassium elements are kept open, then the moisture present in the atmosphere can react with this and explosion of metals can happen. So, in order to avoid this, usually sodium and potassium metals are kept stored in kerosene. So, this is the reason why these metals are kept in kerosene, so that water cannot react with these metals. Calcium can also react with the water. Normally, the reaction goes like this: calcium hydroxide will be produced along with the hydrogen gas, and this chemical equation is also exothermic, but the heat produced during this chemical reaction is not sufficient to catch fire. The hydrogen gas comes as a bubble, and the calcium sticks to the surface of the bubbles, and they come out and floats over the surface of the water. So, we can understand from the first that all these three elements, that is potassium, sodium and calcium, can react with the cold water. Dear students, magnesium cannot react with the cold water, they react with the hot water. So, here this is hot water and the product formed will be same here, MgOH twice, and hydrogen gas will be produced. This chemical reaction is also exothermic, but the chemical reaction is not violent. So, hydrogen gas produced during this reaction will not catch fire. Now, let us discuss another example of reaction of metals with water. There are certain metals which can neither react with ordinary cold water or with hot water. Some of the metals which react only with the steam. Steam means water in gaseous state which have got high energy, right? So, here elements such as iron, aluminum are the metals, zinc are the metals which react only with the steam. So, let us see that chemical equation also. Here aluminum react with water, then here we get Al2O3, and if we take iron, then iron reacts with water, we get Fe3O4 plus hydrogen gas will be produced. So, the chemical equation is not balanced. You practice, we have already seen how a chemical reaction is being balanced. So, you balance yourself these chemical equations. If you have any doubt in balancing these equations, then you can mention it in the comment section. So, we have seen three different reactivity of metals. One is with normal water, potassium, sodium, calcium reacts, and then hot water, magnesium we have taken as an example. And there are certain metals which react only with the steam, that is aluminum and iron. And here the difference should be mentioned here. Steam means water in gaseous state, so that state symbol needs to be entered here. In water, liquid water, here also liquid, and here also liquid, and hot water, still its state is liquid. But in steam, the water exists in a gaseous state, so this you have to keep in mind. So this is all about the reactivity of metals with the water.
The third chemical property of metals is what happens when metals react with acid. The same chemical reaction we have already seen in the previous chapter. Once again, we have to recall some of the important points we have to see here. Basically, when metals react with a dilute acid forms, metal salt and hydrogen gas will be evolved, which we have already seen. Now, here the reaction of metals with all the dilute acids will not produce metal salt and hydrogen gas. Only with the dilute hydrochloric acid and dilute sulfuric acid, the metal salt and hydrogen gas will be produced. If any metal happens to react with nitric acid, they do not produce any hydrogen gas. Why? Because here nitric acid is a strong oxidizing agent. Because of this feature, what happens? It oxidizes hydrogen and it itself gets reduced to lower oxides, as you can see on the screen. So because of this reason, nitric acid cannot remove or liberate hydrogen gas. The fourth and most important chemical property of metals is what happens when metals react with solution of other metal salts. This type of chemical reaction also we have seen already in the first chapter, that is displacement reaction, right? So when metal is dropped in other metal salt solution, if reactive metal is put in the salt solution, then the kind of displacement reaction will take place, which we have already seen. Look at the screen here. Here when iron is put in copper sulfate solution, if we see the reactivity of iron and copper, iron is more reactive than copper. So here in this case, what happens? The iron displaces copper from copper sulfate. So on the product side, you see iron sulfate and copper is produced. So the entire chemical reaction is followed by change in color. So here sky blue color changes into light green in color, which indicates that the iron sulfate is formed. To understand the reactivity of metals or the reaction of metals with solutions of other metal salt solution, we should understand activity series. In activity series, metals are arranged in a decreasing order of reactivity. As you can see on the screen, that on the top potassium is there, and on the bottom, at the bottom you can see gold, which means here potassium is the most reactive metal, and at the bottom you can see it is gold. Gold is the least reactive metal. So the reactivity, if you compare the reactivity, the topmost element, that is potassium, is more reactive, and the least reactive element or the metal will be gold. So on the basis of this, let us understand how the displacement reaction or how the reaction of metals with salts of other metal salts take place. So this is very important. Let us understand with some chemical reactions.
So let us understand the displacement reaction by taking some examples. Firstly, we will take sodium. When sodium is put in zinc sulfate, then what would be the chemical reaction that we have to identify? In order to find this, here we have got two metals, one is sodium and another one is zinc. We have to find the reactivity of these two metals. Suppose if the metal which is being added in the metal salt solution is reactive than the other metal, then it can capable of displacing the metal from its salt solution. If not, no reaction will take place. So in order to find which element or which metal is reactive, we have got reactivity series. So let me find out sodium. Here we have got sodium over here, and zinc we see here. The element which appears above in the activity series compared to other metal, that will be reactive element. So here in this case, sodium is the reactive metal and zinc is less reactive. So from this very much clear that sodium is capable of removing zinc from zinc sulfate solution. So in that case our product would be sodium sulfate, that is Na2SO4 plus zinc. Clear? So it is activity series which helped us to identify the reactivity of metals sodium and zinc. So with the help of activity series we can easily find out the reaction of metals with solution of other metal salts. So the thing is we have to find out the reactivity of metals with the help of activity series. So let me take some other examples. So here I am taking copper as one of the metal which is put in magnesium sulfate solution. So this is metal salt solution and here it is metal. Now in order to understand the chemical reaction, we have to find the reactivity of two metals. We have got copper as one metal and magnesium another metal. Let me find out the reactivity of these metals here. So copper, as we can see, copper is here somewhere in the activity series, magnesium as we can see on the top. So magnesium is a reactive metal and copper is less reactive. See here, copper is less reactive, we can write Lr, this one is more reactive. So a less reactive metal cannot remove a more reactive metal from its salt solution, right? So the product would be here no reaction. So whenever such a instance comes, then you have to write as no reaction. So always keep in mind that highly reactive metal can displace less reactive metal from its salt solution. No less reactive metal displace a highly reactive metal from its salt solution. So this is how we can understand the reaction between metals and solutions of other metal salts.
I believe you understood episode number 2. If so, hit the like button and share as much as possible to your friends. And if not, subscribe this channel right now by pressing on the subscribe button and press bell icon for notification. So that's all we have in today's episode. See you all on episode number 3 where we will be learning about how do metals react with non-metals. Till then, take good care of yourself. Bye-bye.